Morning.
Morning.
All right, folks, we'll get started here. All right, so first of all, I just want to make sure everybody understood what their grade meant and everything else that goes along with that. So everything's based on these grades here: test 1, test 2, test 3, test 4 complete. And the grade as of test 4 is determined based on the lowest of these 4 test grades, not the average. If that grade is an A, then you exempt the final with an A. If it's B, then you can try and take the final and try to get an A. But if you fail the final, then you still keep a B. And if it's C or less at this point, then you need to take the final. So the final will be at 8 a.m. You've got to start between 8 and 9 a.m. on Tuesday. All right, does anybody have any questions? Anybody have any questions? Okay. Yeah, Alex.
Yeah, it's 8 sections. Is it like 2 sections from each chapter, or?
Not necessarily. So you're referring to file study guide. I was going to go through this. So when I say 8 questions, it's like 8 question groupings. So let me clarify what I mean by question groupings. Okay. Let's have a look. Test 1. So Alex was asking if it's going to be two from each test. That's not necessarily the case. These are question groupings. Like question 1 would be test 1 would be questions 1 through 4. This is another question grouping here, the reaction orders. And that's another question grouping there. So there'll be eight question groupings on the final from the 4 different tests that you took. So the best way to practice for the final is to take these ungraded copies and to practice them. Does anybody have any questions? So any information you got with the test, yeah, and you'll have 3 hours since it's online, so you'll have 3 hours to take it. But you are expected to type your work into the last box if you want partial credit for your work. That's why I've given you 3 hours to do it. Does anybody have any questions?
Yeah, I have a question.
Yes, Reese.
As far as the SSI extra credit, does that only apply to the average of our scores?
No, it applies to the aggregate of your scores, which means everything added together. It has the effect of lowering what you need to get on the final to get the grade you want.
Okay. And then we still have to use the automatic calculator on the final, right?
Yep.
Okay.
Yeah, it's again I can't tell that, and Autolock will often flag people who are holding calculators when I haven't put that in as a condition. Again, I can't tell the difference.
Okay.
I know people don't like it, but it is usable. Does anybody have any other questions?
I have something about the test.
I'm sorry, Alex, I couldn't understand your question.
During the last test 4,
Mm-hmm.
I swear that when I was doing one of the questions, I think it was molality or molarity concentrations.
Mm-hmm.
I swear the question changed when I was doing it and when I submitted it.
No, that's not possible. I'm sorry. It just
Okay.
is not possible. Alex, you probably got mixed up between that question and another question. You know, that's much. No, that just doesn't happen. I mean, if you had proof of that, then yeah, I'd entertain it, but I don't think it's possible. Does anybody have any other questions related to the final?
Is each question worth the same amount of points, or is it like
Yes,
our other tests where
each grouping of questions is going to be worth the same amount of
equal
points.
points?
Yeah.
Okay, great.
Actually, Reese, let me back up on that. They're going to be worth the same point values as they were on the tests. I don't know that they would be worth any different. So if you had a grouping of questions that was worth 40 points on test 1, it'll be worth 40 points on the final. But I think they're pretty much going to be about the same. They may not be exactly the same, but they'll be close.
Okay, yeah. I was just wondering because I know that the questions that are more intense and I have like more work to be shown and stuff are worth more. So I was wondering if that was like the same situation. So it's
right. Yeah. Well, yeah. That's usually the way it goes anyway, right?
Yeah, it makes sense.
Okay. Does anybody have any other questions they want to ask about the final? Well, it's in the end, it's up to you how well you do on the final. I mean, it's all going to be a matter of how much time you want to spend practicing those other tests. My advice would be to practice the things you didn't do well on. The final is supposed to be about redemption. So it's about a chance for you to show me that you do understand the stuff that you didn't understand when you were doing the tests. So that would be my best advice to you. Many of you are going to have to spend probably a good 10 hours or so on, and you should budget about that much time to study for the final. Just walking in and taking it without studying anything is going to be a complete and utter waste of time for you. That much I can guarantee. You're going to have to put some time into it. More time than a lot of you put into the tests. I know a lot of you waited till the day the test was due to do anything on them. And I think that was a massive mistake, but there's nothing I can do about that. Now's the time for you to make up for that behavior and actually put some work in prior to the final, as opposed to just waiting until the day of the final to study. I know it's been a tough semester, but there's still, that doesn't let people out from actually doing the work that they need to do. It's crunch time, folks. Time to deliver. All right, does anybody have anything else that they wanted to talk about with regard to the final? Did anybody want me to go over any specific question groupings?
I would appreciate if you could just go over how exactly to do the log and the exponents with the honor log calculator, just because we haven't done it since the first test, and I just want to make sure I do it correctly.
Okay.
Please.
Okay, so let's say it was you want to do log of something. Oops, let me clear this out. Okay. No, see, if you put in just log, it's just going to give you an error. So that's not the way you would want to do it. All right, so if you do 236 and then ln, that gives you the value. So it's just like a regular calculator in that way. Now, if you want to put in an exponent, 6.022 EE, you notice it goes grey, it's sort of a darker grey color, and you do 23. And then you could, well, let me do an equation that involves two exponents.
Okay. Yeah, that would be great.
So let's say, I'll bring up a thing here. Oh.
Is EE like 10
times 10 to the power of, right? Just like it is on a regular calculator. Okay. So let's say it was that. The way you do it, I'm going to clear this out. .622 EE 23, then divided by 6.022 EE 23. I think I did 23 here, but it doesn't matter. That's how you end up with the number.
Okay. And then so for log and ln, you do the numbers and then you hit the button.
Yeah, see, I just did that. I had a number up there, I hit log, and that gave me the log to base 10.
Okay. And then if we're doing exponents, you hit the number and then you hit y to the x and you hit the number that you want it to the power of. Yeah,
that's right. So let's say you want to do, well, let's do this one. Let's do, I haven't done this in a while, so I want to make sure this is okay. So let's say it was, and we'll do times 10 to the negative 23 of this one. So this is a cube root, right?
Right.
So let's see. I'll have to see if this works or not. I haven't done this. But I'll know if it works. If it's working in a second. 6.022 e, and yeah, so negative 23. You have to do the plus minus button over here, like that. And then if you want to do a cube root, you do this one here. This would be to the power of 1/3. So you take this and then hit 3. So you notice how it's dark gray, and hit 3. And there you go. That would be the correct answer for that one.
Okay, great.
But if you want to do y to be x, if you want to cube something, then it would be that, and then hit y to be x, and then the number.
So for to cube it, yeah.
Yeah.
Okay, yeah, because the other one was cube root.
If this was a cube root, this is useful for one of the problems that we did. The solubility problems.
Yes. And then question, as far as on test 4, it's the one where you're doing the I forget the word, but basically it's the one where we have a final answer and we have to multiply it by 1.9 1.x10 to the 9th gilojoules to get gilojoules for it. When I do that one, I'll put it in the calculator with all this stuff and I'll come up with a really large number because the number is supposed to be like 1.23 times 10 to the 13, but it doesn't put it into scientific note or into the different notation. How do I get this to put it back into a notation that I can type with the decimals for?
Are you talking about AMU? And...
Yes, the one where we convert AMU.
Okay. Just take the number. Just take the numbers. Don't even look at the E equals negative to 27. Just write that down somewhere. Get your final answer. And then just take the 10 to the negative 27 and 10 to the 16. Add up those numbers together. And whatever your final answer is for that, for me it was e to the 3rd, and then apply it to your final answer and you should be good.
All right.
That's a little more complicated than what I did, Reese.
Yeah, I'm going to let me go ahead and show you.
Okay.
This I'll show you.
Reese, I just counted after I did that, I got a big number too. I just counted until it was like the first value. I counted all the way and it gave me like 13 or 12. And then I
around 13.
Yeah, so then I just took that number and if it was like 2.666 is whatever, I counted all the way until it was like 2.6 times 10 to however many placements it was. And then I put that into the honor log calculator times 1. I put everything in parentheses and then I did, I multiplied it together, divided it, excuse me, and then I got the final answer.
Okay.
This one here, right, Reese?
Yes.
Okay.
Yeah.
So let's see. I'm gonna pull the honor log calculator out here. It's a separate window. Okay. I'll do this one from the beginning, okay?
Okay, thank you very much.
Okay. All right, so it would be 4.1662 plus 5.1795 minus 3.1227 minus 6.3557. So you can do this all at once. See, it comes out as a negative value, which is what you expect here. But I would just ignore the negative value from this point. Or if you want to, you can change it to positive, but there's really no need. Okay, so we've got our, that's the mass. So we've got to convert that to kilograms. So times 1.6605 times 10 to the negative 27. EE negative 27. And then that's times the speed of light squared. And what I would do for that is it's 2.998 times 10 to the 8th. I can just square it here, but what I prefer to do is just multiply it twice. Right.
Multiply it twice rather than mess with parentheses and stuff. So just do it.
Right. Yeah, that's
a
what I
good
would
idea.
do. But you can,
Yeah.
I mean, there's nothing to stop you doing the square, but you don't even need to
Yeah.
do the parentheses really. But that's just my thought on it.
Okay.
All right. So you get this 10 to the negative 11 value here.
Mhm.
And then we wanted to, we want to multiply that by the Avogadro's number to get the per mole. Right, and that gives us this. Now it has to be in gigajoules. Now gigajoules is 1 times 10. This is that big number you're talking about, right? Is that right?
Yes.
Yeah,
Yes.
okay. But you want to convert that to gigajoules, and that means you divide it by 1 times 10 to the 9th gigajoules. So you do divided by 1 EE 9 equals, right? And there's your number.
Okay, okay, great. That's a lot easier. Okay.
So, I mean, the trap sometimes people fall into is they see 1 E9 and they want to do 10 E9 or something like that. But 1 E9 is what you would put into the calculator. That's any calculator, by the way, not just the on-a-lot calculator.
And then because this has 5 significant figures, we would put an answer as 1119.
It really wouldn't matter that much because there's tolerance on this. So the significant figures
Okay.
aren't really going to be figured in here at all. The reason I want it in gigajoules is so that you can have a number that you can type in there, and it's going to be in the thousands or tens of thousands,
Okay, great.
or possibly hundreds of thousands, but no more than that really. It's otherwise, I don't want anybody having to enter exponents or anything else into the answer box.
Okay, great.
All right. Does anybody else have any other questions they want me to go through?
Is this test 4 or any question?
I'm sorry, Alex, I couldn't understand you. Oh, any question, Alex?
Any question? Can we do buffers?
Okay. Okay. So let's look at question 16 here. Buffer is made up of equal volumes of this acid and then the base. We add HCl. How many moles of A are present, A minus are present after addition of HCl? Okay. So just a little bit of background here. So a buffer is always going to be a mixture of A minus and AH. if you add H plus, then the A minus plus the H plus will turn into AH, which means AH goes up and the A minus will go down. And if you're dealing with OH minus and AH, then the AH will react with the OH minus, not the A minus. And what will happen is the AH will go down and the A minus will go up. Now, in this instance, we've got the HCl being added. So we know what's going to happen is that we're looking for A minus. So we know the A minus is going to go down. So the idea will be that we'll find the initial moles of A minus. And we also need the initial moles of H plus. Now the initial moles of A minus is going to equal the molarity, which is 0.853 moles per litre, times the number of litres we have, which is 0.4061 litres. .346. Now the moles of H plus it's pretty much going to be figured out the same way. It's going to be 0.608 moles per litre times 0.00886 litres. So that would be 0.00538 moles. So to get this result, it's going to be, as I said up here, the A minus is going to go down when the H plus is added. So it's going to be these two values subtract. So moles of A minus minus moles of H plus, and that'll give the result, which would be 0.848, I think. All right, is that okay, Alex, for that one?
Yeah.
Okay, I think I just did. Okay. Sorry, I just did number 17. That wasn't 16. Now to do 16, we're looking for AH after we add sodium hydroxide. So you can see that what happens there is that the AH will go down and the A minus will go up. So in this case, we do exactly the same thing. We find out the moles of NaOH and we find out the moles of AH here. And then we subtract because we know the AH is going to go down. So it's the same kind of story, just a different, a little bit of a different setup. Is that okay, Alex?
Yeah.
Now, for this answer, the table is never going to change. It's always going to be what's going to happen is that at equilibrium, the AH is going to go down by a certain amount. So you're looking for X minus delta. And the A minus is going to go up by the same amount as the H plus. So you're looking for minus here and plus over here. So you find the answer that has that. And plus delta at the end as well. Okay, and for this one, you need to find that the pH of the buffer. So it's doing the same things as we just did, except you're going to do it on sort of a larger scale now. So you need to find the initial moles, and it would be for AH, for A minus, and then for, in this case, what is it? Sodium hydroxide, OH minus. And it's always the molarity times the liters in each case. I'm not going to do the actual math here, Alex, if that's okay.
Yeah, it's fine.
All right, so initial moles, and then we want to find our reaction moles after that. And we need the reaction moles for AH and for A minus. Now for AH, it's going to be the initial mole of AH minus the initial moles of OH minus. And A minus is going to be initial moles of A minus plus initial moles of OH minus. That goes back to what I had before. The recognition that the AH is going to go down and the A minus is going to go up. So this negative and positive are going to be important here. Then we look at concentrations. And that's going to be the moles of AH divided by the total volume in liters. And the moles of A minus. And then you'll have your equilibrium here. And what you'll be looking for is the concentration of H plus, which can then be converted to a pH. And we're using the Ka, and we have to solve for the H plus. And then find the pH. And these values here are the ones that go into the equation so we can solve for the H plus. So I'd recommend that you go take a look at the videos that go along with that as well. It's very similar to what you have to do on a pen and paper test as well with that. Is that okay, Alex?
Yeah, that's good.
All right. Does anybody have any questions? Any other questions you want me to go through from any of the tests? I'm on test 2 right now, so if there's something from test 2, that'd be good. Niloufar?
Could you go over non-standard E-cell calculation?
So the way these are set up, it's always anode first, which means that we have to take the reduction potential, which would be this, and convert it, which says, what's that voltage there? It says 1.58 volts. We need to turn that into an oxidation. Put it over here. Which changes that to negative 1.58 volts. And then I have to choose the equation that involves MnO4 minus and Mn2 plus. And you can see there's two different ones up here. Use this one, the one that has the MnO4 minus and the Mn2 plus in it. So you just take that entire equation, it's already been balanced. Now the total there is going to be negative 0.07 volts, and that's going to be E naught cell. And then in order to make this work, you've got 5 electrons and 4 electrons, which means it's going to be a total of, on the top, it's going to be 5x, and then on the bottom, it'll be 4 MnO4 minus. Plus, let's see, 8 times 4, 32. Gives 5x4 plus and 4 Mn2 plus, and then 16 waters. So what we need here is the Q value, and the Q is going to be, in this case, Mn2 plus to the 4th x4 plus to the 5th over MnO4 minus to the 4th and H plus to the 32. Okay, I'm going to stop there for a second. Nilüfer, do you see what I've done so far?
Yeah.
Okay. So then what we do is we substitute all those different values in there to get a Q value, and then apply the Nernst equation, which is given here. So the E cell then is E naught cell, which is from here.
When you were bringing down everything to form the final equation, why did you bring down the x to the 4 plus instead of the x?
Because if you look at what we're given here, so we're only given concentrations for things that are here,
Okay.
right? So, and the concentrations are always going to be things that aren't solid, and water is not going to be part of it either.
Okay.
Now the N value here is going to be 20. That's 4 times 5. That's whatever it took to make those electrons equal. And then it's log whatever we get for the Q here. And that's how you'll end up with your final answer.
So as far as typing it in, we can put our E naught cell and then just do minus 0.0592 divided by 20, and we don't need any parentheses or anything, and then just hit log Q.
Well, times, well, what I would do is I have the, well, I don't really want to come up with the whole Q value. Let me make something up here. Let's say it was
Okay.
5.6 times 10 to the 8th, right?
Okay.
For the Q. So what I would do, let me see. I'm going to see if I can pull up the unlock calculator here. All right, let's clear that out. So we've got whoops. So let's see how we can do this. 0.0592. I think we could probably do it in one go here. All right, times. And then I do 5.6 times 10 to the 8th. And then I hit log and see where that goes. And then hit equals. And there's my answer. Now, if you want to be sure about it, the other way you could do it, this would probably be the way I'd actually do it, just to be super sure about it. So let's hope we come up with the same answer. So you could hit equals here, then hit log, then times 0.0592. Divided by 20. It's probably going to be something different. Yeah, all right. Well, maybe that's the better way of doing it then. So do the log first and then multiply it by the other things. I think what I did with there was that the log was on the 8 and not the 5 times 10 to the 8th in that case.
Yeah. So you hit log Q and then multiply that by 0.0592 divided by 20, multiply that by your E0 cell.
Subtract from the E0 cell.
Okay, yeah, subtract from E0 cell. Okay.
Yeah. Yeah, do the log first. I think it's probably the safest thing to do.
Okay, great.
All right, any other questions? Any other questions anybody wants me to go through?
How do you find reaction order?
Now, you do remember that I have videos for all of these problems, right? In the quizzes, Alex?
Yeah.
Okay. I mean, I don't mind going over it. I'm just saying that, you know, you can do that. So reaction order. So let's say you're looking for the order with respect to A here.
No, I know how to
No,
do that
no.
one.
No, which one do you want? Which one do you want to do?
It's like they give you a couple of values and they ask you which order is 0, first or second. I think it's for,
Oh, okay. You're talking about this one.
yeah.
This one?
Yeah.
Yes. Okay.
Yeah.
This one requires a little bit more work. So what you would need to do if you've got A, then you would need a natural log of A, and you need 1 over A. And you find the natural log and 1 over. And the idea is you want to figure out which of these is going to be a straight line. So what you do is you find the slope between what I recommended was the slope between the first 2 points and the slope between the last 2 points. And the slope is going to be delta y over delta x. The times, which you already have, they're the x values, and these are the y values. So whichever one comes out to be close on the slope comparisons, that's the one that the order is. And this is 0 order, this is first order, and this is second order. And we know that from up here, where I've given you the integrated rate laws, which are the 0 order is A, first order is log of A, second order is 1 over A. Is that okay, Alex?
Yeah, that's perfect.
Okay. But again, you know, I have a video for question 5 on the below it, you know, below the link to ungraded copy of test 1, and it goes through and it shows you exactly how to do that. It does a full example. So you should look at that as well. All right, does anybody have any other questions you want me to go over on any of the tests? All right, if nobody has anything else that they want to ask about, then you know, we'll leave it here. Does anybody have any last questions about the final in general? So that in your grade report, those scores you need to get on the final in order to get the grade you want, those are accurate, those are calculated. That's exactly what you need in order to get the grade that you want. So make sure you understand that too. All right, well, we'll leave it there for today then.
Thank you.
Thanks for coming. And if you need me, email me, call me. Right?
Thank you.
Okay. See you later.
See you. Bye-bye.
Bye.